We're going to do a little bit of talking about quadratic word problems. Now on Tuesday, I threw in a word problem for you to look at to see whether or not you could interpret what all of the pieces of the parabola mean when it comes to a word problem. So if you want to take a look back at Tuesday's 8.3 worksheet, you can take a look and follow along. Otherwise, it's right here. The height and feet of the soccer ball that's kicked was modeled by a function. Now remember, f of x is just another way of saying y. In this case, they're telling you that x is representing the time in seconds after the soccer ball is kicked. And we want to graph that function. So we know that it's a y to begin with. We know that y equals is the same as f of x. First thing that we're going to do is we're going to find out what the vertex is by solving for x first. So we use the formula negative b over 2a, and when we do that, we ended up with x equaling 3/2. Now this is going to be one of those cases where I tell you that fractions are your friends, and this is so much easier than changing it to a decimal of 1.5. When we substitute in 3/2, first we square it. 3 squared is 9, 2 squared is 4, but now you can simplify this, and you can also simplify this and end up with whole numbers. So we discover that y is equal to 18. Great, but what did that mean? Well, here's what it meant. It meant that 3/2 is the x and 18 is the y. If you really don't know where to go from there, take a look at the actual graph. The label of the x-axis says time. The label of the y-axis says height. So if you take a look at the vertex that you've discovered, you'll see that the x is 3/2, 1.5, and the 18 is the height, just like the y. So first let's talk about let's put in the axis of symmetry. So the axis of symmetry goes on the 1.5. Now it's okay to use decimals because it makes more sense to say 1.5 seconds than it does to say 3/2 of a second. Next, we know that the height is 18. So the maximum height is 18, and the time that it took to reach that particular height of 18, it took 1.5 seconds to get there, but then it would take an additional 1.5 seconds to get down to the ground. You'll remember from the video from Wednesday that it said that parabolas are symmetrical. Therefore, what it takes to come up to that point also takes to get down to the ground. So the total time in the air was from here to here. 1.5 in this section, 1.5 in this section, for a total of 3 seconds. Now you're going to do one. It's kind of similar, but you're going to do this. The height of a dolphin as it jumps out of the water at an aquarium show can be modeled by the function below. The x represents the time in seconds after it exits the water. Now you know already just by looking at it that this is a parabola that's going to open downwards. Mathematically, I know that because the a is a negative. I also know that if a dolphin's jumping out of the water, it's going to make an arc. First, find the axis of symmetry by finding the x. Find the vertex. What's the y-intercept? You found that the vertex was 1,16. So of course that means that the dolphin is going to be jumping out of the water and it's going to reach its vertex at 1,16. Again, what does that mean? The 1 is your x-coordinate. It's the time that it would take for the dolphin to get to that vertex? And notice that it's time in seconds. The 16 is your y coordinate. Look at the label on the y-axis. That's the height in feet. So what's the maximum height that the dolphin is going to reach? How long will it take for the dolphin to reach the maximum height? And last, how much time will the dolphin spend in the air? If I graph it, you'll be able to see that I have my line of symmetry. It took 1 second for the dolphin to get to the highest point, and then it'll take 1 more second for it to come down back to the water. The word problems that you're going to be working on today is in the form of a Google form. Please make sure that you read very, very carefully and submit your answers.